Welcome back, programmers. Today we're talking about variable scopes. Yes, 6 of them. The default scope, global, shared, protected, static, and finally the very advanced threaded. We'll see them all. We'll see how to use them. We'll see how they work. And let's get started. So first scope is the default scope. When you put no scope at all, basically, you write a variable, you write define.type, the name of the variable. This uses the default scope. The default scope is not accessible from modules and from procedures. Okay, so let's look at this example right here. Define name $ equals Bob, so string variable, a name. Procedure display, I want to display name. If I run this, it fails, telling me that the variable has to be declared. I have my enable explicit, so it should, okay, that's why it's telling me name $ has to be declared. It's available right here. So if I just comment this out, okay, but I put the line within it, and instead of calling the procedure, I'm just calling this code here. Boom, here that works. Bob is displayed. But if I call it within the procedure, it doesn't work because the default scope is not accessible within procedures or within modules. Next scope is global. Okay, so global variables are accessible from everywhere except modules. So here the variables are accessible from the procedures. So you write global.type name.type. So either you put the type, of course, on the global or on the name, just like the example right here. Okay, global name, once again, Steve. I have my procedure. I'm going to display Steve here, my name. And here in the procedure, I'm going to change the name to Linda. And then here in the code, I'm calling display. So this should display Steve, change to Linda. And then when I'm calling the message requester once again in the main code with the name, the name will have changed. Let's look at that. First time Steve, I'm in the display procedure. See, the title here is procedure. Okay. Next time main, I'm in the main code and it's written Linda. The name variable has changed. Okay, it's the same variable here. It's the name $ variable, and it is accessible from within the procedure, and you can even change it within the procedure. And of course, you can change it and access it from the main code. That's for the global, but let's check a specific example for the global variables. Control B for the commenting. Let's check it with modules. Okay. So here, I know I haven't done any video on the modules yet, but you should see a module just like an independent piece of code. So inside the module, you need to repeat the enable explicit, and you can have variables. So here I'm declaring my module. So first I have a city $ global variable, once again a string, Paris. I have a module, okay, called PP for pure programming, by the way. Enable explicit, I have a global variable within my module, and I have a procedure within my module. These are public, these are accessible from the outside of the module. Okay, from the main code, I can access the name $ and I can access the display procedure. Now I'm defining my module. I repeat my name $ that I initialized to Bill. I have another global variable, but that is not in the declaration, that is not accessible from the outside. Age, it's an integer. and I define my procedure display, which is going to do a message requester displaying in the title module, and then name is age in city. Okay, I'm using all variables. I'm using the global variable here of the main code. I'm using the age, which is a global variable but private to the module age. So okay, and I'm using the name $, which is a global variable of the module but accessible from the main code. Then after that, I change the variable name to Kirsten, and I change the age variable. So in the main code, what do? I call the message requester with the global variable, which is here, so that should work. I call the message requester checking the variable names in my name $, in my module. Okay, my module has a name $, and here I'm displaying it. Okay, main module variable, and then I'm calling the display procedure twice of the module, because first time it will display something, and the second time it will display different variables, because different values, because I have changed them the first time it is called. So let's run this. Guess, tell me in the comment, what should it do? Fail or pass? I'll let you think about it. Look at the code. Let's run it. Yes, it fails because, let's run it again, sorry. City $, is not known to the module. Yes, the global variables in the main code are not accessible from within the module. So here, city $, doesn't work. Okay, I'm going to put that into comments, and then if I run it again, okay, first time, Paris, yes, here I have my message requester, main global variable, Paris, of course, it is accessible, it is in the main code. Then, Bill is the name within the module of my, yes, the name $, within the module, fine. Then I'm calling display, so I'm gonna call a message requester again. Bill is 34. Yes, I'm using the name $, of the module and the age of the module, which is initialized to 34. But now that this is called, I'm changing the name to Kirsten, sorry, and adding 1, incrementing the age. And so Kirsten is 35. I've called my procedure display again, and now it displays the new value of name and the new value of age. So you see now how it works. City $, is not accessible from within the module. Name $, age are accessible from within the module and within the procedure because they are global to the module. But name $, because it is in the declaration of the module, and we'll see that in a specific video about modules, you can access it from outside the module. Yeah, this one is a little bit tricky, but that's how global variable work. Let's comment this. Now the shared variables. Syntax is always the same. Okay, shared.type, name.type. You put the type either on one or the other. Shared keyword allows a variable to be used within a procedure, but the usage is limited to the procedure within which it is declared. It is useless if the variable is global. Okay, but it works. But that doesn't make any sense. Let's look at the example. Once again, I have a default, which is not a global, it's a default variable name $, Alec, and I have a display, once again, display procedure. To be able to use the name $, here within the procedure, I have two ways. You know the first one, I can define it as global, but I don't want to do that because I don't want it to be accessible from within all the procedures, just from the display procedure. So I use the shared here, the shared keyword. And here my shared name, I have to repeat the exact same name here, name $. Then I can use it. I can use it like this in my message requester. I can also modify it, and I'm going to put Brad. So if I call display here, it will display Alec, but the second time it should display Brad. And even if I put my message requester, instead of calling it a second time, I'm going to call instead the message requester, and this will work. First time Alec, second time Brad. Let's check. First time I am within the procedure, it's calling Alec, and second time it's calling Brad. Here I should have said main. Let's run it again just for the sake of good code. Alec within the procedure and Brad within the main code. So it's a way of using variables only in specific procedures. Of course, if I'm defining here the name as global, the shared won't add much value, because here it will do the same, it will work. But the name will be also accessible from other procedures, just like for any global variable. All right. Next is protected. Okay, syntax, you know the game. Protected.type, name.type. Protected variables are local variables in procedures that can have the same name as global variable. They are basically protected from the global variables within the procedure. Of course, the usage of the protected keyword is limited to procedures. Okay, another example. Let's look at that. Name Alec, procedure display. I'm defining a protected variable name, so same name as this one. So this should compile. Christopher. Message requester, I'm displaying Christopher, and here I should say procedure, sorry, and not main. And then I'm changing the name variable to Brad. So what do you think it should do? It's gonna display Christopher, because basically this variable here is overriding kind of this one. So if I run it, you'll see first time Christopher, second time Christopher. But I'm changing it here. Why is that Christopher twice? Because the variable is reinitialized, not reinitialized, but this code here is called, the variable is defined every time you're calling the procedure. So the first time it's defined here with the name Christopher, you can change it here, fine, but the second time you're calling the display, it's also defined here with the value Christopher. So you're never going to use the value Brad. And you can put a global here variable. In that case, this will work again, even if the global variable and the protected variable have the same name. The protected is limited to the display procedure. Of course, in that case, you cannot use the global variable anymore because your local variable has the same name. All right. So that's for protected. Now static. This one is nice. Static.type, name.type, we know the drill. Static variables are local variables in procedures, just like protected, but that keep their value between calls. Okay, usage of the static keyword is limited to procedures, but you see usage, no, they keep their value between calls. Let's look at this example. Like this. Procedure display. So I don't have any global variable this time. Procedure display, I have a static variable string name $, and it's initialized to Christopher. I'm calling message requester. Here, once again, shouldn't be main, but procedure too much, too many copy paste. I'm just displaying the name. And then I'm changing the name to Brad. The first time it should have Christopher, second time it should have Brad, and I'm calling the display procedure twice. So first Christopher, second time Brad. Let's see. Christopher, Brad. That works. So you see that even if it's within a procedure, the name $variable has kept its value between the calls. Okay, first time it was Christopher and second time it was Brad. Even if we change the name to Brad within this, the first call. First call, Christopher goes to Brad, and second call, Brad goes to then Brad, of course. But we are just calling it twice. If I were to call it 3 times, we would have Christopher, Brad, and Brad. Christopher, Brad, and Brad. Okay, what I could do here is, let's say, add, I don't know, X, just for the sake of this example here. Let's see what it does here. Christopher, first time. Second time, Christopher X. Third time, Christopher XX. Every time we keep the same value within the procedure. Okay, but be careful in the way you are initializing the value within the procedure. If you want to have an initial value, you should do this in one line, in one statement here. Static name equals value. Why is that? Well, it's because if you do it this way, okay, looks like the same. If it were in the main code, it would be exactly identical. But here we have the static keyword, and we are within a procedure. If we do that and we run this, what's going to happen is we are going to have Christopher, Christopher, Christopher. 3 times Christopher. Why is that? It's because the static variable is defined here. But this line here tells, okay, we put the name back to Christopher. Every time we are calling the display procedure, we are putting the value Christopher in it. So of course, this is never going to be used, because every time we are going to call it, it's going to erase whatever is in the name by Christopher. So you should, of course, initialize your static variables just like this. Imagine that when you're calling the display procedure, only the first time the procedure is called will this line be run, kind of, okay? The name $variable, the static variables, keep their value between calls. Okay, and that's it for the simple scopes, okay? Default one, global, shared, protected, and static. And now I have just a quick example on an advanced scope. Let me comment this, and it's the threaded scope. Syntax still the same, okay? Threaded.type, name.type, whatever you want, okay? Threaded variables are local to each thread. Each thread has its own copy of the variable. In each thread, they behave like global variables, okay? For threads, sometimes you need to have variables that are local to the thread. For each thread that is created, you want the thread to have its own copy of the variable. You don't want to have the variable shared between the threads. And that's how you use the threaded keyword. Okay, let's look at the example. Maybe it will be clearer. Okay, so here I have a threaded variable, name, a threaded integer, count. One is 42, the other is default. I have a structure, thread info, with just a name. I have a procedure, thread. In the parameter is a thread info. Okay, it's a pointer. As for when you pass structures to procedures, you pass the pointer. What do I do here? I initialize the name. So remember, the name is threaded, the threaded variable. I initialize the name to whatever is in the thread info. I'm initializing the count, which is protected to this procedure. And I'm just displaying, using the debug function, I'm displaying thread count and space and the name. And what do I do in the code, in the main code? I'm defining two thread info, RI and JI. One is called Robin, one is called Joe. So I will have two threads. One I want to name Robin and the other Joe. Here is the best part. I'm defining the two threads. Robin, I'm calling the create thread. So that's a PureBasic function for multi-threading. Create a new thread running in the application. Okay. So the procedure that's going to run within the thread is the thread here. No, sorry, it's the thread procedure. Sorry, yes, it's so we pass the address of the procedure with the @ here. @thread means I'm going to call the thread. One thread is going to run this procedure. The other thread is going to also run this procedure, but both with different parameters. This is the parameter that's going to be passed to my thread procedure. So I'm passing for one thread RI, the thread info for Robin, and to the other thread I'm passing JI, the thread info for Joe. And then here, this code is just waiting for the thread. Okay, wait until the thread ends, not ends, wait until the thread ends. And I'm waiting for Robin, I'm waiting for Joe, and then I'm just displaying the name variable here. So let's run this just to see what it does. Okay. Here I have my debug. Thread 17, Robin. Thread 17, Joe. And I have a T here. Why is that? I have no idea. Let's run it again. So my default here is the threaded name in my main thread. I've initialized it to default. So when I'm calling the message requester here, I'm displaying default. And I'm passing so the two threads, one is Robin, the other one is Joe. Thread 17 is Robin, thread 17 Joe. Okay, the 17 is always the same value. So that's not a good example, but that's an example for local variable within the thread. Okay. And in fact, I could even protected. No, I cannot do that. So the result is thread 17 Robin, thread 17 Joe, and you see here the name $ here refers to the name $ here, which is the threaded. Okay. I should have named it differently. Let me try to do something different. Let's call it here with a T name for threaded name. Okay. Threaded name here is here and it's here. Okay. The name $ within the structure is just called name. And here. So thread 17 Robin, thread 17 Joe. And let's do something once again different. Sorry, it's a very tough example to grasp. It's an advanced topic. Here, instead of doing this, let's call it random. Okay, random, I don't know, don't care, 10, 100. So here, one thread should have a random number, the other another random number. Okay, good example. So thread 49, Robin, thread 41, Joe. So the variable tname $ is local to each thread. We are initializing the variable here when I'm calling this procedure to whatever is in the thread info. So Joe or Robin. Then the count is random, and then I'm displaying thread count plus space and the thread name, the tname. And here for the first thread you have Robin, for the second thread you have Joe. That means that you don't have the same value for both variables, and that works. If I were to put a global variable, I cannot do that. I need to stop first. If I were to put a global variable here, and you see the threaded.i count 42 here is not used at all, because it's only used, so this one is just useless. So here that works again, but look at that. Here Joe. So what's happening here is I've defined my tname $ variable as global, not threaded anymore, global. So it's not local to my thread, it's global to the whole application. So every time you modify it, it's available for the whole application. So when I'm calling the create thread here, it's calling thread twice, once with Robin, once with Joe. First time it's called with Robin, so it's initializing to Robin. Then Joe initialized to Joe. That's why at the end we have Joe here. We don't have default anymore, we have Joe, because the threads, even if they're using this variable, it's a global variable, so it's available for the whole application, for all the threads. And if I were to wait a little bit, let's say we can wait a random number of time. Let's do something like so let's say I put a delay here. Delay, yes, I'm gonna, yeah, random. Random of what? 500 milliseconds should suffice, right? So here, first thread is gonna wait a random delay between 0 and 500 milliseconds. Same for the second thread. So maybe these calls will be in a different order. If I run this, Robin, Joe, Joe. If I run this again, Robin, Joe, Joe. It doesn't work. Does it? Robin, Joe, Joe. See? That's my example here. Joe, Robin, Robin. Once again, the variable is global. So depending who is accessing it first, it will end with the Robin or with the Joe name, Joe value. Okay, that's okay. So just to sum up, threaded variables are local to a thread. They can have different values depending on which thread is running it. Okay, if you put a global variable, the variable will be shared between all threads, which is completely different. So that's how the threaded scope works, and that ends this video on variable scopes. Well, that is it. Don't forget to like, comment, subscribe if you have any questions, or if you think I said something completely stupid. That might happen because I'm still learning those things. Just tell me in the comment, tell anything that go through your mind about scopes, of course, about PureBasic, about the channel, about me. That being said, thank you all for watching, and I will see you in the next PureBasic 101 episode, or maybe another video, I don't know. Bye.